So in order to look at Vectorization Advisor, we're going to start with a simple example. We'll use the Vectorization Advisor to provide a report for this simple program. So here are the steps to use Vectorization Advisor. First, include advisor-annotate.h. Second, there are two directives we need to place at the beginning and the end of the code you want to take a look at. They are annotate_site_begin and annotate_site_end. Finally, you simply run the advisor tool. So here is this very simple example program. The first thing it does is it calls a function to populate the data array. Then it calls a function to add numbers to the entire data array. So the populate data array just randomly generates 100 values, and the add to adds 5 to each element of the data array. Now you might notice that I've added these directives in here, and that will tell Vectorization Advisor that I want it to take a special look at this. Let's see, we're going to set a breakpoint here and go ahead and run this. And just to show you there's nothing up my sleeve, this is actually doing vectorization. And the way you know that is with this move DQA. That's one of the vectorization Intel CPU opcodes. So let me quit that. Now I just simply run the advisor. And actually I've already run it on this piece of code. So I'll just go through and rerun it. And it runs the application and gathers data. And it's going to show you that there are no vectorization issues, which is what we'd expect because auto vectorization works really, really well for simple code. Sometimes vectorization loops, however, have dependencies that prevent them from being fully vectorized, or maybe even auto-vectorized at all. So we're going to add to this simple example, and we're going to add a loop which should be vectorized, but has dependencies and may encounter difficulties. Here is the new function that I added, and you'll notice that there's nothing fancy about it except the dependency. Data sub I, we're adding data sub I minus 5, which is a dependency. And in the past, this has been very difficult to auto-vectorize. And here I'm making the call. Okay, so let's run Vectorization Advisor and see what it says. Now, I have 3 loops here. This first loop is generating the random numbers, which can't be vectorized at all. The second one was that simple loop, which can be vectorized fully. And this third one is the loop with dependencies that we want to vectorize, but we were suspecting we may have difficulties with. You notice that it says 23. So what that tells me is that it realized there was difficulty and it somehow accommodated for it. So to explore this, we'll go back and set a breakpoint. And now we're going to go ahead and run this and see what the disassembly looks like. So you'll notice this is a lot more complex. And this initial code looks a lot like what you would see if you hadn't vectorized at all. In other words, what it's doing, it was smart enough that it was able to take the initial part of this where the dependencies would be a problem and create non-vectorized code, and then go on here to create the vectorized code. So in conclusion, I highly recommend the use of Vectorization Advisor. It can give you the status for all potential code vectorization. It's really easy to use, All you need to do is add a few simple directives, and this will let you make sure that your code executes as fast as possible.